Bismillahirrahmanirrahim. Assalamu alaikum. Welcome back to my YouTube channel. And we are learning about the non-covalent interactions. And this is the third video in the series. So previously we learned about what are the non-covalent interactions and then how to prepare your input file for working with them, like the fcheck file from Gaussian and .molden file for Oka. And in this video, we're going to work about the finding the potential maximum and minimum values on the surface. But before that, I just want to tell you if you want an fcheck file from this Molden input file of Orca, which we got in the last video, if you want to see how to convert the GBW to Molden, just watch the previous video in the series. And now, if you drag this Molden input file into Multiwfn and press enter, then we can easily convert it to the fcheck file. And for that, we need to first go to this number 100. So type 100, press enter, and then you go to this export various files. That's number 2, enter, and then you go to number 7, which is here, output current wave function as the fcheck file. If I press number 7, enter, now it's asking me to write a name, but if I want to keep the current name, just press enter and it will be written. You see here is the file that appeared. And if I just open it in Gauss view, you can see that, yeah, this is the same molecule. And here is how we converted the Oka GBW file to an fcheck file that can be easily read and worked with in Gauss view. So now we will work on, I'll reopen the Multiwfn. So now we will work on a file. For example, I'll drag this file in here and press enter. Now, in this video, we're going to do a quantitative analysis of the surface, molecular surface. So to find the maximum and minimum potential on the surface of the molecule. So first of all, I'll just tell you quickly about VS Max and what it is. For example, let's open this file in Gauss view, and if we go to surface and contours and we plot its total density, and let me tell you the VS Max is basically, so if we just plot the ESP. So we mapped the electrostatic potential on this molecule. So you can see that there are different colors in here, and this area or place seems to be more on the positive side, and this whole portion is more on the negative side. So what is the maximum potential, or in other words, it's called VS max. VS max is basically the local maximum of the molecular electrostatic potential located at a, like this called sigma hole, or you present it at a chosen isodensity. And minimum is the value where the electrons are more concentrated. So VS max would be an area of positive which is attracted to the negative centers, negative partners, and VS minimum would be the areas which are attracted to the positive partners. So let me minimize this, and let's actually go into this analysis and see. If I press 12 for quantitative analysis. Now, if you want to change any setting, like change the density, isodensity, or other things, or you want a finer grid, you can change from these options, but I'll just do the start analysis for 0. So if I press 0 and it did the analysis. So now you can visualize the surface, view the molecular structure, surface minima and maxima. That's what I'm going to show you. I press 0. And here we go. So now if you look at the molecule, you got, let me just remove this axis. And you got various points in front of it. And if I just show the minimum label and maximum label. So yeah, So these ones, the red ones are maxima and blue ones are minima. So you can see that it shows you various labels like number 8, that's a maximum. And here in Multi-WFN window, you can see the number of surface minima and surface maxima. So let's say this area, which was right in front of iodine, as you saw here, this area, probably if I move the molecule in the same way. Yeah. So yeah, it looks like this now. So it was this area, this blue area, which has number 8, and you see that its value is 41.655 kilocalories per mole. So that's because it is generally represented in terms of energy on the chosen surface. So that's the value of Vs maximum. And then you got various minimum values as well. But there is one caveat of the multi-WFN that you cannot really rotate the molecule. To do so, you have to like press this up, down, left, right. And yeah, that's about multi-WFN. But it's good that you can find all these values and those maxima and their numbers, and you can correlate here. And the maximum values are indicated by a star here. So now, if I just close this, you can save a picture from here if you want, and then you can return. And as soon as I return, it shows the menu again. So if you want to export these surface extrema as a surface analysis.txt file in the current folder, you can do that. Just press 1 and enter, and it will save a file with this name in this multi-WFN folder. And yeah, so let's stop it here. And now, if you want a beautiful picture like this with surface extrema on top of it, and you can move it and see where are those exactly, then you can also use VMD for this. And I'll tell you how to do that in VMD. So for setting up VMD, you have to copy these various files from the examples to here and then change path. But luckily, I have prepared this multi-WFN setup for you that I showed you in the last video. Um, I have put it on GitHub. You can download and everything is set up. So now you don't need to do anything. You just need to rename this file. So to rename it, I'll just make it its copy and rename it at 1.fch. So if you just rename it as 1.fch, and now you run the script espiso.bat, and yeah, just double click this one. It will take this 1.fch and produce a density.cube file and then move it to VMD. And now if you want to show the ESP extrema as well, so you have to run this file espext.bat, double click, yeah, and you are done. So now let's go to VMD folder, and you have VMD here, and you see that it has produced the function1 and function2.cube files here and density1.cube as well. So if I run VMD and just bring down this command prompt window here, a bit slow. But anyways, yeah, here we go. We got the VMD, and now if you type here in the command section, just write ISO and press enter. It will show you the molecule here. Let me just zoom out. Yeah, here it is. And then if you want to show the surface extrema on top of it as well, just write here EXT and press enter. So now you see you got the surface extrema and exactly at these places where they should be. And these golden ones are the surface maxima and the blue ones are surface minima. So you can easily rotate and see. And from multi-WFN, you can actually see their numbers and get their values from the surface.pdb file, and then you can match. So now you know the areas on the molecule that are mostly positive or negative, and this can be very useful if you are modeling a reaction or something and you want to know about the surface properties of a molecule, like where the nucleophiles will attack, where would be the place to electrophiles to attach, or so on. And yeah, you can also work on sigma holes if you want. So the sigma hole, you would have learned about the term sigma holes in front of the halogen atoms. They can also be made from this process. And yeah, that's what was about the surface analysis of the molecule. I hope you would have learned something new. And if you have got any questions related to this, you can post in the comment section, and I'll try to get back to you as soon as possible. And yeah, in the next videos, we'll try to learn about using the aim analysis, QTAM analysis, and then NCI analysis as well using multi-WFN. Until then, please allow me to leave, and thank you very much. Bye bye.